So we did once upon a time a thing called expanded notation. So expanded notation's a little bit back today. We're just doing a thing called expanded notation but with exponents. So let's first just do expanded notation. Can anybody take 4,097 and remember how to write that in expanded notation?
Like, should we spell it out?
Nope.
The word
4,000
Nope.
plus 9.
Anybody memories?
4 times 1,000. 9 times 10. 7 times
And that's in the neighborhood for sure. We need a little bit of stuff still fill in.
8. Parentheses around everything.
Parentheses like around the whole problem or each little group? Okay, so each little group has parentheses. I agree with that.
And then addition.
Agreed. Okay, that's going to lead us into what we're doing today. That's not what we're doing today, but that leads us in. What we used to do with expanded notation, we would take each digit, like 4, times its place. That was in the thousands place, so we did 4 times 1,000. We'd ignore zeros. 9 is in the tens place, so we did 9 times 10. 7 was in the ones place, so we did 7 times 1. It was just a way when we did that. Basically, it was when we were learning place values, it helped us practice on place values, essentially. Question about that, what we did. Okay, so here's the change today. We're still going to do 3 groups. So it's still going to look like that. But instead of writing out the place values, we're going to write the place values with power. Here, I'm going to write 10 to the third. Anybody have a theory on how I would know to write 10 to the third on this?
Because 10 times 10 times 10 is 1,000.
10 times 10 times 10 is 1,000. Another way that we could know quickly that we should write a 10 to the third.
10 times 100.
That's true, but something else showing on here that I can make this transition kind of quickly.
There's 3 zeros.
With 3 zeros, just put a third power on them. Another way we could do that is just look back at where we came from. What does 3 have to do with this? If we look back to the original number,
There's 3 digits, right?
there's 3 digits after it. So I'm going to go 4 times 10 to the third because there's 3 things after it. For the 9, there's 1 thing after it. So I could put 10 to the 1 because there's 1 thing after it. For 7, I'm going to go times 10 to the 0 because there are 0 things after it. And that's what we're going to do today inside of that. Question about that? Here's one more in that direction. How many groups is this one going to have?
4.
4. One group has to do with 5. The next group is 4, 3, 7. In each group, we're going to go times 10 every time. If you remember back to maybe the first week of school, I gave you a paper with million, billion, trillion, quadrillion, quintillion, hextillion, all the way out to like Google and all that stuff, if you remember that. Okay, on that paper, that's how they wrote all these place values. They didn't write out like trillion with 12 zeros. They wrote that as 10 to the 12th. That's just a common thing that happens in math as you get older. The powers of 10 kind of replace the place names. But magic power on this? Still?
6?
6. Why 6?
Because there's 6 places after the 5.
There's 6 places after the 5 for this one.
4?
Drop 4. 3. Why 3 for this one?
3 places after?
There's 3 places after it. From 3's point of view, 2 things after it. From the 7's point of view,
1.
1 thing after it. What did I forget temporarily on purpose that we need to backfill? Addition. We want to go adds to separate each group. So half the homework, they'll give you what's called standard notation or decimal notation, depending on their mood. And we'll write expanded notation. The other half the homework, they'll write the expanded notation, and they want you to work your way back. Question about those. Okay, so what we're trying to do here is have a 4 that has 5 things after it, including a 3 that's common, including a 2 that's common. The 4 is going to have 5 total things after it. What's the 3 gonna have after it?
Two.
2 total things, one of which is gonna be,
Two.
2. And the 2 is gonna have
Zero.
no things after it. So if we're gonna have 5 total things after it, what's gonna appear in this answer to fill some spots?
Zeros.
Zeros. We're gonna need some zeros to help fill this up. So one way you could do this is write 4 and just kind of gently put 5 blank spaces down. A, B, C, D, E. The 4 has to have 5 things come after it. Where do I need to drop the 3? Into which position?
C.
The C position. I need the 3 to drop in here where there's going to be 2 things after it. Where would I need to drop the 2 in? The F, all right, it's a messy E, but yeah, we drop the 2 in that last position where there's nothing after it. In your final answer, I don't want all these weird blank labeled spaces, but what's going to go in these empties? Zeros. And if you wanted to make those weird little blanks, just when you're done, erase them. If you're doing those weird little blanks in your mind, that's fine too. What's the only thing I'd criticize about this answer still?
Commas.
Commas. Where should I drop that comma?
After the 4.
Not quite.
Not before the 3.
Before the 3. We'll start from the right and go 1, 2, 3, comma, and then we've got 3 over there, so that one's okay. I can make up more problems if you don't get it. If you get it, you get it, and we'll move on. If you don't get it, I'll do it again. Does anybody need me to make up another problem to go from the standard number to make the expanded? Does anybody need me to go from the expanded to make the standard or decimal notation? Anybody need another sample to do it? We're in the back. It's just the next set up, set 00. So 00, the first 15 are like the last one we did, where you go from the parentheses to the, they're going to call it decimal notation. And then the last half, they're going to go in the other direction. So set 00, that is it.